everyone, this is Taiki again, and I'm going to present the last problem on the team round, team number 10. Rectangle ABCD has AB equals 8. Let M be the midpoint of side AB. Suppose there is a point P on side AD such that CM is perpendicular to BP. If CP bisects BPD, the length of CM can be expressed in that form for some variables, and we want to find the sum of M and NP. So, as always, we start with a diagram. We're going to try to draw as accurately as we can, though we don't know that many length yet. So we have ABCD, and we have M is the midpoint of AB, so here. And then we're going to draw CM, and then the point on AD, so it's perpendicular, so something like this. Perpendicular, and the CP bisects BPD, so we can draw this line here, and these two are congruent angles. So from here, we're going to have some observations. So first of all, we see that AD is parallel to BC. That means that by transversal CP, we have that this angle here is equal to this angle here. But since this angle BPD is bisected, we have that this angle is also equal to this angle BPC and BCP. That means that BPC is isosceles with BC equals BP. Next up, we want to draw another altitude to make use of the fact that BCP is isosceles. So we're going to drop a perpendicular from P to BC. We're going to call it R. And we're going to call intersection of CM and BP Q. And we see that because BC equals BP, the lengths CQ and PR should be equal because they come from sides of equal length. So then we see that AB equals PR because AB and PR are both perpendicular to AD and BC. That means we know that AB is 8, so PR also equals 8. So now, the next step is we're going to assign a variable, let MQ equal X, and AB equals 8, so M is the midpoint, so we have MB equals 4, AM equals 4 as well. Now we're going to use the Pythagorean theorem on BMQ. So hypotenuse is 4, and Q is x. So this is going to be 16 minus x squared, the length of BQ. And because BPC is isosceles, we also have that BR equals 16 minus x squared. Okay, so then we see that PR equals 8. So we have Pythagorean theorem again on BPR. So 16 minus x squared plus PR, which is 8, and then squared. This becomes 80 minus x squared. So that's the square of the length BP. And we also have from back here that BC equals BP. So this is also equal to BC squared. And then finally, we can use Pythagorean theorem on BMC. So we have BM is 4, so 4 squared, plus BP squared is 80 minus x squared, so that's also BC squared. So we have 80 minus x squared equals CM squared. Well, CQ is 8 from what we saw earlier, because PR is 8, so we have 8. And then MQ is x, so we have 8 plus x, and this is all squared. So now we can simplify this equation. We get 96 plus x squared equals x squared plus 16x plus 64. And then we can move stuff to the same side. 32 equals 0. Then we get dividing both sides by 2. We get x squared plus 8x minus 16 equals 0. And now it's just a quadratic formula, so negative 8 plus or minus 64 plus 4 times 16, 64 over 2 equals -8 plus or minus, well, 64 plus 64 is 2 times 64, so we can take us root 64 out and get 8, and then we have a root 2 left. And it's all over 2. Now, because x is a length, it must be positive, so we choose the positive side, and we get -4 plus 4 root 2. But now we want to find the length of CM, so we have to add in the length of CQ. This can be done by adding 8, and we get that CM equals 4 root 2 plus 4. So the answer will be 4 plus 2 plus 4, which equals 10. And we're done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.